Creating references using inheritance hierarchies. In this video, we will show how reference variables of a superclass can be assigned to an object of a subclass in the same hierarchy. The is-a property revisited. Recall, in the first video in this unit, we made the following explanation about inheritance relationships. We stated that whenever we assert that class B extends class A, we are implying that B is a A. For example, an iPhone is a smartphone. A quadricep is a leg muscle. A monkey is a primate. A tiger is a cat. And a Lamborghini is not a shoe. In this lesson, we're going to take that assertion several steps further. If class B extends class A, then an object of type B may be assigned to a reference variable of type A. For example, if I declare a shape reference named S1, I can assign that reference to a circle object because circle extends shape. If I declare a cat reference named C1, I can assign that reference a tiger object because tiger extends cat. If I declare a smartphone reference variable and assign it a new iPhone object, I can do that because iPhone extends smartphone. If iPhone didn't extend smartphone, I would not be able to make this statement. Likewise, if class B extends class A, then an object of type B may be stored in an array of type A, or in an array list of type A. Here's what I mean by that. Suppose I declare a cat array of size 3, and then in the next line, I declare an array list of cat. Because cat is an abstract class, I can assign a tiger object to a spot in that cat array. I can also assign a lion object to a spot in that cat array. I can also assign a cheetah object to that spot in the cat array because all three of these classes extend cat. Any object that extends cat can be stored inside this cat array. Similarly, since the array list stores cat objects, I could add a tiger object to that array list. I could also add a lion object to that array list. I could also add a cheetah object to that array list. Any object that extends the cat class can be stored inside the array list. Thirdly, if class B extends class A, then an object of type B may be passed as an actual parameter to a method that was expecting a parameter of type A. And here's what I mean by that. Suppose in my shape class, I define a static method called getShapeArea that receives a shape object as its parameter. Not a specific shape, just a shape object. I then invoke the getArea method on that shape object inside the method. Henceforth, when I go to the main program and define a circle object, a rectangle object, and a triangle object, all three of those variables can be passed as parameters to the getShapeArea method because they all extend the shape class. In a previous lesson, the following question was asked. What is the point of giving the shape class a getArea method if we're just going to have to override it in each subclass? That question is answered by the most recent example. Because the shape class contains a getArea method, this guarantees that every subclass of shape will have a getArea method, either through inheritance or by overriding the original. For this reason, Java allows us to define a getShapeArea method that invokes the getArea method on its shape parameter. The reason Java allows it is because it knows that any subclass of shape is guaranteed to have a getArea method. Had we not declared getArea in the shape class, we would not be able to make that guarantee, and thus Java would not allow this code to compile. It is also worth noting that even though getShapeArea invokes the getArea method on any shape object that is passed to it, that does not mean the same version will be invoked every time. The version of getArea that gets invoked will depend on the type of shape the method receives, whether it's a triangle, rectangle, circle, etc., etc.